Hello guys and welcome to another video. Yes, I'm not using the headset because the built-in microphone is actually pretty decent for the camera. Alright, in this video we're going to be talking about half equations. Now half equation can come up in many topics, but mainly in chemistry we mainly get half equations in things like electrolysis, fuel cells, storage cells and all that. So it's essential to understand how half equations work. Now why are they called half equations? Well, they're essentially half an equation. So if you combine two half equations together that actually makes sense, then you get a full equation. Now half equations, the way that we are going to talk about, or I am going to talk about, are mainly oxidation and reduction reactions. Now we're going to start off with a bit simple with oxidation reduction. Now let's understand what oxidation and reduction means. Now there's two meanings for each of these words. Reduction can be getting an ore on its own using carbon, or reduction can mean the gain of electron. Oxidation can mean oxygen is gained or electrons are lost. Now the definition we're focusing on is reduction is the gain of electrons and oxidation is the loss of electrons. One way to remember this is oil rig. Oil oxidation is lost. Rig reduction is gain. That's one way to remember it. Now let's take an example of a half equation. Here we got iron leads to iron 3 plus 3 electrons. Now this is basically when iron is produces rust essentially. Yeah, and now the type of reaction this is oxidation because it loses electrons. Now you might be confused because it says plus 3e minus, but if we move the 3e minus this side and rewrite it as Fe, actually if we change this arrow to an equal sign, bear in mind it's not actually an equal sign, you can see that if we rearrange to get Fe3 plus on its own, Fe minus 3e minus, because minus is the charge here, and it's a 3 plus because it has 3 more protons than electrons, but it doesn't gain any protons due to electrons being lost. It has a 3 plus charge because now there's 3 more protons than electrons essentially. So if we do Fe minus 3e minus, we can easily get Fe3 plus. Now here we can see here it's losing electrons because it's minus, but in chemistry apparently they don't like a minus being written, so we have to write in this format right here. Now since it's loss of electrons, it's oxidation, and yeah. Now one simple rule to follow if you don't understand reduction oxidation, how you can tell which one it is. If the electrons is on the right hand side, it loses electrons. If the electrons are on the left hand side, it gains electrons. Now that's one way to remember if a reaction gains or loses electrons. Now how can we tell if an element needs to lose or gain an electron? Well, this can be done looking at the periodic table. Now generally elements in group 1 to 3 generally need to lose 3 electrons. So they will be involved in oxidation reactions where they have to lose the electron. Elements in group 5 to 7 normally need to gain electrons, and I'm saying normally because this doesn't always happen. And group 4 is like a mixture, it can be like gain or lose electrons, but for these purposes, GCSE purposes, we're not gonna go through group 4 elements, or more mainly not group 5. The main elements you might get group 1, group 2, group 7 and parts of group 6. Now what does the groups actually indicate? Now group 1's, the group number represents the number of electrons on the outer shell. So if we have group 1 elements, they all have 1 electron on the outer shell. Group 2 elements, they all have 2 electrons on the outer shell. Now by that, if we can tell, oh forgot, I dropped my pen. If we can tell by the group number, we can easily tell how much what ion is going to be essentially. I'm stuttering a lot. Now if we have, for example, sodium, it's in group 1, so it only has 1 electron. Yeah, so if it has 1 electron, it can easily lose it. It's easier for it to lose, so it will form +1 ions. One thing to know is that metals mainly or always form positive ions, so they mainly lose electrons, whilst non-metals mainly form negative ions, so they gain electrons. That's one way to keep in one thing to keep in mind. Now let's put this into test, shall we? Now you might get a question where it says magnesium is in a reaction to form magnesium ions. Now we need to know what group magnesium is in. Magnesium is in group 2, and how can you tell what group it is? Look at the periodic table, and magnesium is Mg. You will find it is in group 2. If it's in group 2, it will most likely form plus 2 ions or 2 plus ions. So it will lose 2 electrons. So if it loses 2 electrons, the electron must be on the right hand side. So if you write it down like this, Mg leads to the formation of Mg ions. So it will most likely be an Mg2 plus. So if it's a 2 plus, that means it lost electrons. So if it lost electrons, that means we need to write plus 2e minus here. Now why do we have to write the 2e minus here? Because if we look at, there's 2 electrons, they both have -1 charge. So if they both have -1 charge and this has a 2 plus charge, add them together, -2 plus 2, you get a neutral charge of magnesium. Because here there's like a 0, it's a neutral charge because protons cancel, the number of protons cancel out the number of electrons in terms of charges. Now that's the example of a metal. Remember, metals always form positive ions, mostly. I don't want to confuse other people, or if any teachers are watching this, so they don't get triggered by me. Yeah, so they mainly form positive ions. That's one way to remember. Now let's take an example of a non-metal. Now the thing with non-metals is that they can come as diatomic or just single atoms. Diatomic meaning it comes in 2. So like oxygen always comes in O2, and all the halides or group 7 metals always come in 2 atoms. So chlorine always comes in 2, fluorine always comes in 2, and bromine always comes in 2. So let's take an example of a halide or group 7. If it's a group 7, it has 7 electrons, and to complete an outer shell you need 8 electrons, so it's easier for it to gain. So that means group 7 elements, all of them form -1 ions or 1 minus ions, however you word it out is fine by me. So let's take an example of chlorine forming chloride ions. Now if you hear the word "ide" in it, that means it's basically an ion, a negative ion. Now chlorine, as I said, all the elements in group 7 are diatomic, so chlorine will be diatomic because it's in group 7. So we'll write chlorine as Cl2. Now it will form chloride ions, so we'll have a -1 charge, so it'll be a Cl minus. Yeah, but then we can't write Cl2 because it's actually the bonds between the chlorine are broken up. So it was bonded like this, for example, and the bond is basically broken up in this reaction, forming 2 separate chlorines. So essentially we have a 2 right here. Now since there's 2 chlorine atoms and each chlorine atom needs to gain an electron, so this chlorine atom will have to gain an electron and this chlorine atom will have to gain an electron. That means it gains 2 electrons. So since it gains, it will be on the right hand side, so I forgot to put a little bit space here. So here will be Cl2, and so it needs to gain 2 electrons because it needs 1 here, 1 here. So it will be plus 2e minus. And that's how you can get 2Cl minus. Now let's take an example of a group 6 element, oxygen, and we know oxygen comes as diatomic. So the formula for since it's a non-metal, it will gain electrons. So we know that there's going to be a plus on the left hand side, and on the right hand side will be by itself. So we know oxygen comes by itself, and oxygen is in group 6, so it needs to gain 2 electrons. But since there's two oxygen, that means it needs to gain 4 electrons, because if we draw the shape, if I draw the outer shell of oxygen, so it will have 1, 2, 3, 4, 5, 6. It has 6 electrons because it's in group 6. It needs to gain 2 more right here for it to gain a full outer shell. But there's 2 of these oxygen atoms, as you can tell by this number right here. That means it needs to gain in total 1, 2, 3, 4. It needs to gain 4 electrons in total. So we'll put a plus 4e minus right here. Now the resulting the oxygen atom will be O, obviously, but we can't put a O4 minus because you're essentially saying it has 2 electrons, because if you put O on its own, and we put, like, let's say we put O2 4 minus, that does not really work, because you're literally saying that there's two more atoms and all that, but also the bonds are broken between the oxygen, so it won't be O2 because they're not bonded together anymore, so it'll be 2O. But it won't be 4 minus, because if you do minus 4 times 8, you get minus 8, and that's not equal to the minus 4 right here. So here, this side has minus 4, this side has minus 8 if you do this format right here. Also to remember, oxygen cannot be 4 minus as well, because if you think as oxygen by itself and you put a 4 minus right here, you're saying that, let's say the outer shell is essentially full, but you're saying it creates another shell with 2 more electrons, which does not make sense because it's not a full outer shell. It won't react just to get an extra shell with 2 extra electrons without getting an outer shell. So what we'll do here is oxygen always form 2 minus ions, so we won't do a 4 minus, we'll do a 2 minus right here. So if you see, if we do 2 minus times 2, we'll get a minus 4, and they're both equal on both sides essentially. Now one thing to do now, metals normally do not come diatomic. You will write them as a singular atom, so Na, Mg, Mn for manganese, if you did not know that, or Cs, cesium and all that. Yeah, the all metals, you won't write them as 2. Now one thing that you might see in questions, they might say copper 2 for example. This 2 is essentially a thing saying it's a +2 ion. So if it's a +2 ion, that means it lost 2 electrons. So this is essentially telling you it's ion state, so it lost 2 electrons. That's what it's essentially telling you. So if you wrote copper, the symbol is Cu. So if you write the formula for copper forming copper 2 ions, you write Cu, and since it's a metal, it will lose electrons. So we won't do any electrons right here. By the way, how can you tell if an element is a metal? Just look at the periodic table. There's a little line that says if it's a non-metal or not. It should be distinct. I can't easily describe it, but there should be like a little line like that separates the metals from the non-metals. That's how you can tell if it needs to gain or lose an electron. Back to where we were. Copper leads to copper 2 ions. So we are 2 plus ion. Now, essentially, copper is in the transition element, so yeah, it doesn't have a group. But this number 2 right here tells us how many electrons it lost. This number 2 says that it lost 2 electrons. So if it lost 2 electrons, right on the right hand side, +2 E minus. And that's essentially how you did. Now here's a question for you guys to try. Sulfur forming sulfur ions, that's the reaction. Assume that sulfur is S4, so there's 4 lots of sulfur atoms. One thing to do, say that sulfur is a group 6 element, so use that in mind to see how many electrons it needs to gain, because sulfur is a non-metal, so it needs to gain electrons. Pause the video and do it. Now hopefully you answered the question. If not, I'll just do it. So yeah, I'm gonna rub this out so I get a lot of space. So I said assume that assume that sulfur is S4. Now, one sulfur atom needs to gain 2 electrons. So if there's 4 sulfur atoms, it needs to gain 2 times 4, which is 8 electrons. So here the equation will be S4, and then obviously if it's on the right hand side, it gains electrons, so it will be plus 8E minus these 2, and then alright, S. And then yeah, we know it's an S because the bonds do break up between the sulfur atoms. S. Now here's where people might get confused. They might write, oh, I'll put a 2S here and S, so S22, and say this is oh. Some people might just say, oh, forms 2S, the 4 minus, but that's not true, because obviously how can you have 4 sulfur atoms and have 2 sulfur atoms right here? It needs to be conserved. So since the bonds do break up in this reaction, we'll write a 4 right here because there's 4 separate sulfur ions. so we'll put a 4, then S for sulfur, and then we know that the sulfur will form a 2- charge because in group 6, so it needs to gain 2 electrons, so one sulfur atom will have a 2- charge, and that's how you do this equation. Now here's one last question for you to do is on metals. So remember the rule I gave you, manganese forming manganese 7 ions. Now remember what I told that this is Roman numerals. This V is a 5 and this one line is a 1, so 5 plus 1 plus 1 is a 7, so it's manganese 7 ions. And remember what I did tell you about these type of numbers. Try the question. Now hopefully you guys did it. If not, I'm gonna go through it. So we know the symbol for manganese is Mn, so we'll put Mn right here. And since manganese is a metal, it won't gain electrons, it will lose electrons. So we'll write nothing on this side, but we'll just do an arrow. Then since it forms manganese 7 ions, we know that it has a 7+ charge because of this number. And since it has a 7+ charge, that means it must have lost 7 electrons. So we'll do a plus 7e minus. And that's literally how you do half equations at this type of level. And half equations do get a bit more complicated in electrolysis, but then you should have another other pieces of information. Hopefully you guys enjoyed this video and you actually learned something from it, and obviously I'll see you next time.